Okay, good morning everybody. Today our new week, which week this week I'll discuss about HVAC, heating, ventilation and air conditioning systems. So heating means increasing temperature, ventilation means you have to remove pollutant gas or with a low amount of oxygen or any pollutant is there, so you have to remove, and air conditioning means temperature may be able to increase or decrease. So these three things basically will be there. Then initially I'll discuss about general aspect of HVAC system, why we need this one for your shipping or offshore vehicles or offshore any structure or let's say offshore platforms. Then we'll discuss ventilation and later we'll go for air conditioning details, mathematical analysis, and we'll discuss about uh, your psychrometric chart also, so that you can understand why psychrometric chart or moisture in air also very important for your comfort in the room. Now HVAC, they will be saying HVAC or HVAC and R, air conditioning and refrigeration, HVACR, so different way they will be explaining, and it will be controlling temperature, humidity basically, and air purity. Air purity means like if you have any odor or anything, so it will be removing. Improving energy requirement, so these days lots of research are going on how to reduce energy consumption from your refrigeration system and how to design a building so that it will be requiring less amount of heat or energy from electrical source or other sources. Ventilation system, so here V term is there, that is actually ventilation. It will be replacing air in any space, so it will be controlling temperature, oxygen replacing, removal of moisture, odor is there, smoke is there, heat, dust, airborne bacteria, carbon dioxide, other gases is there, all the things will be removed through ventilation mechanism. So ventilation mechanism you have seen, like ventilator fan, you are very much familiar with, or if you open your window also, air will be circulating, so that is also one ventilation purpose. So comfort of passengers and crew in the quality of transported goods, so many goods will be there, say medicine will be there, many products will be there, chemical product which needs lower temperatures. In that case also ventilation is very much important. Ventilation and air conditioning, HVAC, is very much important. And comfortable temperature, for room comfortable temperature 24 to 30 degrees centigrade, relative humidity will be 40 to 60%. Later we'll discuss in detail. Here I'll explain a little bit simpler term. You say I was in Aberdeen temperature, when the maximum temperature, very high temperature become 30 degree, so the Scottish people, their faces become red actually, because they feel that is very hot and we feel very much comfortable. So that depends on person to person. Okay, so some South Indian student was there in Aberdeen, so in summertime also they will be putting heating system on. Okay, because normally South India temperature higher and Scotland temperature very low, so summertime it is very much comfortable, still feel colder. Okay, even I was also feeling colder actually during summertime. Okay, relative humidity normally it will be 40 to 60%. So lower relative humidity, what will you do, it will be drying your skin, especially during winter season. If you are in North India or West Bengal, that side, because of drying skin, if you scratch your screen, you can say white sort of thing will be coming up, and sometimes screen will be broken and crack will be created, and sometimes blood also be coming up. Okay, because of dry skin. So in that case moisturizer you have to apply, right? Lots of company are doing business because of this dryness. And what about if relative humidity is more than 60%? So what is happening in Kolkata? If in especially in during August, humidity will be very high. Okay, so during humidity very high, actually you feel suffocated because of high humidity, and clothes will not get dried quickly. It will be smelly. And lots of skin disease may also come up. Okay, so very high humidity, very low humidity also not required. So you have to put optimal level of humidity. Let's say normally people say 40 to 60 degree, 60%, not degree, and comfortable temperature 24 to 30 degrees centigrade. So many people will be putting AC at 20 also. Okay, and many will be putting at 29 around. So based on your person to person it varies. Okay, or geographical location. Say Scottish people, if they are putting air conditioner, definitely they'll be putting at 20, right? In Chennai normally will not be putting 20, will feel very much cold, so normally we'll be putting higher, maybe 25 around. And relative humidity, anyway, it will be auto control by your air conditioning system. Okay, it will be maintaining. So later we'll discuss how to maintain that relative humidity, how mechanically it is working. Okay, now if you see this temperature and relative humidity in different cities, I have taken from Google, just Google weather. So Chennai 38-degree temperature, relative humidity 61%. So you see the temperature is very high, right? So if you reduce temperature, then actually relative humidity will be changing. So in that case, actually you have to take some action. You have to remove some moisture. Then you have to you can make your room or any cabin you can make comfortable. Okay, Delhi 28, 32% relative humidity. It is very low. Okay, so in Delhi side, same air conditioning mechanism may not work. Delhi side you can use actually desert cooler. So desert cooler in Delhi side, if you are from Delhi, you will be knowing that lots of water vapor will be going into air, and if when you air is getting lots of moisture, temperature will be lower. But in Chennai, people do not use that desert cooler because Chennai humidity already high, 61%. If you are adding more humidity, you are increasing relative humidity much higher, then temperature will be going down, but your humidity will be high, so that will make much more uncomfortable. So that's why Chennai people will not be using your desert cooler, but Delhi side, UP side, your Rajasthan side, they will be using desert cooler in summertime. It's very much effective there. Okay, Jaipur, if you see 30-degree temperature, relative humidity 30. So again, you have scope to increase relative humidity. When you are increasing relative humidity, actually temperature will be dropping, so you'll feel comfortable. Lakshadweep, you can see again relative humidity higher, so you have to reduce relative humidity there. Okay, and if you see Alaska, temperature already negative, so reducing temperature doesn't make any sense. Actually, you have to put some heating system, okay, to make it comfortable. In Chennai, normally this normal passenger vehicles, they will not have any heating system. But if you go to colder countries like UK, so there will be car heater inside car. Car heating system will be there, so you'll feel comfortable inside car. Okay, London temperature presently 9 degree actually. Okay, but relative humidity very high. So if you are reducing relative humidity, your temperature will be down. So it will not help. So you have to do some mechanism. So you have to increase temperature. If you increase temperature, actually automatically relative humidity will be down. So that mechanism can be used. Okay. So later I will discuss how things will work. Okay, but I want to explain you that different cities, different location of geography location, they will have different temperature and humidity, and we have different humidity and relative humidity and temperature comfortable zone. Okay, so within zone, if we are making our room, then it will be very much comfortable. If you are going outside zone, it may not be comfortable, or it may be creating some other issues. For example, breathing, suffocation issue also will be coming if moisture is very much high, or moisture is very much low, then again dryness will be there. Okay, so you can see this Riyadh, 16% relative humidity, Saudi Arabia, right? So it is very low. But Lakshadweep, London is 86%. It's very high. All right. So during rainy season, especially like continuous rain will be there for several days. Sometime that humidity will be going to 90% or more actually. So in that case, your clothes will not get dried, so it will be very much smelly. Okay. So in that case, you should control your relative humidity. Okay. So both you have to control relative humidity plus temperature. Okay, and other thing are there, like for example dust, smoke, other thing like bacteria, virus, anything is there in atmosphere, in air, so that also you have to control. So right side one picture I have shown here how things are working. Like say polluted air is here, and polluted air will be going through certain mechanism, you can see here, then you are getting filtered air. Okay, so this is our actually collaborator Magneto, and company in Delhi. So they are making this air purifier, so you can go through their website and you can check what they are doing. Now heating, especially in colder countries, so heating means especially colder countries, colder locations. Okay, so passenger vessels HV system is second largest energy consumer after propulsion system. So normal passenger car in Chennai, it will be using 20% of your fuel if you are switching on your AC. Okay, for your passenger ships also, up to 30% energy can be consumed by your air conditioning or HVAC system, heating, ventilation, air conditioning altogether. In some cases you have to heat, you have to increase room temperature, in some cases you have to reduce temperature, again you have to control moisture also. So altogether about 30% energy can be consumed by system. HVAC this is the primary energy consumer when ship is berthed at the port. Okay, when it's not moving, propeller is not moving actually, so that time it will be taking the maximum amount of energy. Okay, normal passenger car 20% fuel cost. Okay, normally 2 kilowatt power will be required. Okay, 1 ton refrigeration system or 1 ton air conditioning system will be used. Okay, about thumb rule. The term ton of refrigerant, you can see the definition. So you should remember the definition, actually very much important. Whenever you want to buy any refrigerator or your air conditioning system, they will say, sir, what is the tonnage? Okay, so you have to know that one approximately. Unit of power used to describe heat extraction capacity of refrigeration and air conditioning system. Here I will tell you one thing. Refrigeration and air conditioning mechanism almost same mechanically. Later we'll discuss okay, there will be one evaporator coil, condenser coil, compressor coil, all these things. So mechanism is same. Refrigerator, you are creating very low temperature, but in your air conditioning system, you are creating temperature around 20 to 30 degree, within that range. Normal air conditioner in India, I have seen minimum will be 18, maximum will be 30 or around. So within that range you can control actually. Okay, so normal room temperature for comfort, room temperature will be like 25 to 30 degrees centigrade, and for your food storage in refrigerator, -1 to 4 degree. Okay, food storage in your fridges. Okay, it will not be -1 normally, it will be normally 4 degree around, but if you are going to deep freezer, then it will be much more negative also. Okay, but deep freezer, it will have less than 0 deep freezer. So all the refrigerator, they will have one deep freezer condition also, where you can create ice also. You can put your food items, say meat, fish. So those items must be frozen below 0 degree. Okay, so -15, 18 degrees centigrade temperature will be there. Dry ice, if you want to produce dry ice. So in that case, your temperature will be like -70 degrees centigrade. Dry ice means carbon dioxide you are making solidified, and -70 to -200. So if you are making liquid gas, -70 to 200, -200 degrees centigrade. So making liquid gas, liquid air, let's say nitrogen and other molecules, you want to make liquid nitrogen or liquid oxygen. So in that case, within that range you have to work. So this is called cryogenic temperature, very low temperature you're creating. So later we'll discuss what is cryogenic temperature, how to create it mechanically. Okay, so why these things are required to know, because one side you are reducing room temperature and making it comfortable, another side you have freezer, passenger ship you are designing, you have freezer. So you have to know food preservation temperature, deep freezer temperature, and many cases you transport many food item and many chemical item also, which needs very low temperature. Okay, so that also you have to know. For example, liquefied natural gas, LNG. So you are creating liquid, so that means you are creating low temperature. Okay, so and your container must have all these facilities. So that's why you should know the temperature ranges for this. Okay. One more thing, tone of refrigerant here, definition is that 2000 pound 907 kg ice you are creating. So that is called ton of refrigerant at 0 degree centigrade in 24 hours. Okay, so this is the definition. Now here ton does not mean like 1000 kg. Is this short ton? So in US they use short ton, one is long ton will be there, another will be metric ton. Metric ton is actually exactly 1000 kg, and short ton is 907, and if you say long ton, so in that case it will be 1016 that. Okay, so this short ton, that means 907 kg, and exact definition they have given now, 12,000 British thermal unit, this much of energy you are transferring. Okay, or 3.516 kilowatt energy you are transferring. That is the new definition of ton. So ton of refrigerant means 12,000 BTU per hour. Okay, whenever you are buying any refrigerator or any air conditioning system, so you have to talk about tonnage of refrigerants. So type of room heating system. So one is that forced air heating system. So you have one furnace and you blow air. So the whole room will be, air will be circulated and temperature will be controlled. Another radiant heating system, like I was in the UK, in Scotland. So there they had one radiant system. Okay, so inside there will be some coil, hot fluid will be passing through the coil. Hot coil means pipe actually. Okay, through this hot fluid will be passing through this one, and this one metal sheet. So when hot fluid is passing through this one, metal sheet will be heated up, and this will be radiating heat inside room continuously. So gradually the room air temperature will be going up. Okay, in South Korea I was there. So there they had floor heating system. So the floor, they will have some coil or some heating mechanism. So floor will be heated up slowly. Floor will be radiating heat, and because of high temperature, the air particle will be moving up. So whole room will be heated up gradually. Okay, and in North India side, if you see heating during winter season, they will be putting simple coil, like electric coil they'll be putting, and some curved way so that you can get heat directly. All right. So electric space heater, they say. Portable electric resistance heating device. So resistance heating, that one actually. Okay. They normally in UP or North India side, people will be using during winter season. Okay. Some many other type of heating, also fireplace heating are there. For example, older houses, if you see in colder countries, there will be fireplace inside room. So there will be burning coal or wood, and they will be increasing room temperature. There will be heat pump also in some cases, somewhere heat source is there. So you pump or make some natural circulation system, so the room temperature will be increasing gradually. Okay, so and many cases people will be using your exhaust heat to increase temperature. So exhaust heat you pass through some pipe, and the radiated heat will be inside room. So radiated heat will be increasing temperature, but the exhaust gas you are not putting inside room, rather that heat you are using for room heating purposes. But everywhere you are not heating room. For example, some vessel is there in Chennai, you are not heating the room because Chennai temperature already high. But when vessel is moving towards colder countries, so there you may need heating room. Okay. Ventilation. So to change or replace air in space, to control temperature, remove moisture, odor, smoke, heat, dust, bacteria, carbon dioxide, while replenishing oxygen. So two main type of ventilation system, mechanical and forced ventilation or natural circulation will be there. So mechanical ventilation, like you have air handling unit, you have a fan, normal like your toilet system, there will be fan, or many rooms also will be having fan, ventilator fan, so that room air will be pushed out of the room, so that fresh air can come from other sources. Let's say door will be open, and from door it will be entering, right? So kitchen and bathroom often will have mechanical exhaust fan. Okay, this will be controlling odor and humidity. Okay, ceiling fan and floor fan circulates air in summer, reducing perceived temperature by enhancing evaporation. So ceiling fan actually it will be circulating more. So when air circulation is there, so more evaporation will be there. So because of more evaporation, we will feel more comfortable. So ventilation without fan, mechanical system. So door or window you keep open, so that will create natural ventilation. That is also possible. Okay, so that used one term, air changes rate. Okay, normal air conditioner system, like whatever air conditioner system running here also, so there will be 5 air changes normally. So 5 times, 1 time, 2 times, 3, 5 times air will take from room. After that it will be pushing out to the room. Okay, but in many cases like hospitals, there will be 12 air changes, many times changing will be there. Okay. Okay, so now air conditioner type. So whenever we are talking about room air conditioning system, normally we say in general respect, we say like reducing room temperature. Okay, but if you say Western countries, like say Scotland, where I was there, so air conditioning does mean that you have to increase room temperature. Okay, room cooling does not make any sense because already outside temperature lower. So if you open the window, already room will be cooled, right? So central air conditioning system will be there. So if you see, if you go to your Phoenix Mall, That's outside IIT. So Phoenix Mall, it will be centrally air conditioner. One air conditioning machine is there for a library or even offices also. In our department also, they are putting new air conditioning pipelines. So one centralized plant is there. From there, you are transporting your cold fluid to the rooms. Okay, that will be central air condition. Or new academic buildings also, they are having central air conditioner. Instead of putting individual air conditioner in each room, they put centralized one system. Okay, uh, another split air conditioner. Centralized is a very big system, very big houses, very big malls, school or let's say big building, NSC building. So there you are putting one machine and you are cooling whole room, building. And a split air conditioner. So these are split air conditioner in this room. Split air conditioner means normally air conditioner will have one condenser. Okay, so in split air conditioner we will have one condenser and one evaporator coil. Something more will be there. I'm not showing now. Okay, so condenser means like say above the building, sometime you'll be seeing some box is there. Okay, so that is called condenser. So that will be releasing heat. And evaporator means inside pipe, like here some air is coming, cold. Okay, so from there cold air is pushed here, means hot that heat it is taking and it is pushing out to the condenser. Okay, so split condition means two unit, condenser will be outside building and evaporator part will be inside your room. But another is that window air conditioner. In my office room I have one window small air conditioner. Okay, so inside everything will be there, your condenser, your evaporator, and other really all the mechanism will be put inside one box. Okay, so this is called window air conditioner. Okay, the split air conditioner is that it is silent because maximum noise will be coming from condenser and one compressor will be there. So those noise making and difficult part it will be outside building, and evaporate part which is not making such noise. For example, this room is not making noise, right? Only small air blow noise is coming. So this split air conditioner will not give any noise and peaceful cold room you are creating. But window air conditioner, all the compressor, condenser, all mechanism will be there in one box and will be delivering air inside your room. So that's why it is noisy. Okay, so many people will not like window air conditioner, they will be liking split air conditioner. But window air conditioner very small you can make and you can put in small rooms. Okay, because this is one compact unit, you don't have to put separately condenser and other parts some other places. The small unit you put here. Okay, so portable air conditioner, window also one portable air conditioner actually. Hybrid air conditioner also possible, and many cases air conditioning possible using your vapor absorption system. Later we'll discuss vapor absorption system. Actually basically two types of air conditioner system will be there. One will be vapor compression system, vapor compression. So normally window air conditioner, your split air conditioner will be vapor compression system, and vapor absorption system will be for big malls and cold storage system. There will be vapor absorption system because the unit will be very heavy, but very light and compact system. If you want to make, then vapor compression system is better. Okay, so thumb of rule is that for room air conditioning system, like this much of range of heat will be removed. So your tonnage will be like 1 ton around. Okay, so 1 ton around room, like a normal office room will be like this room is bigger actually, but if we see my office room is smaller room, so there will be 1 ton refrigerant AC will be enough. Okay, for big room ton will be higher. Okay, you can 50 to 150, not 15, 150 square feet. This is thumb rule actually. If you go for actual calculation, then you have to do actual dimension you have to take. But normally you say, sir, how big your room? Sir, one bedroom is there, queen size or king size cot is there. So then your AC shop people say, sir, you take 1 ton or 2 tons. Okay. But if you want to go for exact calculation and building design or ship design something, so in that case then you have to see whether room is insulated properly, windows are designed properly, windows, if there are lots of leakages there, your air conditioner cooling but lots of heat will be wasted. Okay, so room windows must be designed properly, ceiling must be designed properly, walls must be insulated properly so that heat should not go out or in. Okay, uh, so lots of things are there. Okay, but we are not going to design the air conditioning system based on this room size and other thing. Rather, we will go for mechanical system, how air conditioning system will be working, how will make comfortable room. Okay, so here I have given one example, just I took from internet. One Volta company, they are selling product, Tata, I think Tata product, this one. They are selling product in India. You can see this one, star rating. So higher star rating is better actually. They will be more energy efficient. Okay. Uh, then cooling capacity 4950 watt. Okay, so this much of heat they can remove. Rated current 6.9 ampere cooling, power input. Okay, then noise level also very low. You can see operation LCD, maximum operating ambient range temperature 48 degrees centigrade also they can work. Okay, and refrigerant, later we'll discuss what is R32. Freon, I think you may be knowing, right? R12, you may be knowing already, because this is a chlorofluorocarbon type. So R32 is there, R134 is there. So many types are there. Later we'll discuss different types of refrigerant. Okay, and yeah, so anti-dust filter also there. So this is one type of window air conditioner actually. Okay, so this is nothing related to ship. That's I want to show this what air conditioner looks like. Okay, airborne pathogens, COVID-19 and other scenario changes. Okay. So in 2020 when COVID started, scenario was different. Now scenario is different because air conditioning system, it will be recirculating air, room air. Okay, it will be recirculating room air, means it is taking room air, cooling it, again sending, again it is taking back, sending. So several times it will be doing this one. After that it will be sending out to the atmosphere. Now when it is doing this one, so if there is some virus, it will be recirculated, it is creating the air turbulence. So one person is having some COVID virus, it will be reaching to others. So that becomes challenge for the designers or air ventilation or HVAC system engineers. Okay, and airborne diseases like measles, tuberculosis, SARS, influenza, rhinovirus, measles, tuberculosis, tuberculosis TB, and COVID-19, SARS-CoV-2, you can say. So these are airborne viruses. Airborne viruses means it will be, if you have any moisture particle, air droplet, water droplet, a liquid droplet, it will be residing in liquid droplet and it will be moving, right? When air conditioner is working and recirculating, it will be taking one virus from here and it will be sending to others. Okay, then what to do? So the building design operational characteristic, okay, they said like increase ventilation rate, lower occupancy density. So lots of people are there, so possibly there more virus will be transmitted. Okay, so reduce number of occupant. UV, ultraviolet ray you can use. So actually we are working with one Royal Academy of Engineering project for designing UV waste air filter design, where we are doing like this. We have one channel, we are taking room air, and inside channel we have put all this UV virus, UV light sense, UV lights. Okay, when air is moving through this UV lights, all the germs will be killed or deactivated. Virus, it is lifeless anyway, right? So when virus will be moving through this UV section, it will be deactivated, or I mean it will be killed, you can say, killing rate we say. It will be killed, and when air is going out, if any virus is there, you are getting without virus or bacterial air. Okay, so that we are trying to design actually. So many company also jumped into that business. Previously it was there, so we are trying to design and optimize the system actually. And one system is there already, a high efficiency particulate air filter. So lots of small sieves will be there, and when air passing through this one, so very small particle also will get trapped. Okay, and it will be dropping very much high pressure also, but it's still fine when you are talking about virus spread, right? So this high efficiency particulate air filter, it will be around 99.97% effectiveness is there, and but particle size 0.3 micrometer or larger it will be stopping. But if some particle size much lower, then it will be having difficulty. Okay, so some virus or bacteria will be larger size, virus may be much lower also, that can get transmitted. Okay, but UV one effective method, so we are trying to develop certain technology. Okay, so types of home purifier like HEPA purifier will be there, absorbent purifier is there, UV purifier is there, ionic purifier is there, ozone generators also there. One company like Delhi in Magneto, our collaborator with this project, so they are also trying to develop ionic based purifier, and UV already we are working together. Uh, so air purifier means here you are not controlling temperature or moisture, here actually you are purifying air for dust or other thing, right? Adsorbent purifier, so it may be made of activated charcoal, so it may be trapping chemicals, odors, indoor environment, widely used in environmental cleanup effort such as spill mitigation refineries. Okay, so charcoal is used for your desalination system, also for odor removal purpose. UV purifier also there, I already told. Ionic purifier is there. Oxygen generator is there. Use corona discharge of UV light to break oxygen molecules, creating ozone. So air conditioner for offshore, one example here I have taken, like Carrier company, big air conditioning company, so they make offshore. And I found some other companies also there. They make especially for ships, your boats, for offshore, especially offshore applications. So they may have specific criteria, especially material and other things must be considered, because offshore is very much salty. So any material randomly you select and you design, it may not work. Okay. So for example, one example is given here. Green speed one, their technical term, I mean, name they have given. So R134A refrigerant they are using, and this much of cooling they are creating, 167 to 495 tons, so very big, actually very large shipping applications. Is water cooled chiller. So chiller means like condenser part will be water cooled, for passenger offshore application. Inverter driven screw compressor, here compressor system they have specified. Screw compressor means like positive displacement. So what happens in air conditioning system, we need one compressor. Compressor will be producing very high pressure but low volume flow rate. When it is producing higher pressure, low volume flow rate, we go for positive displacement type compressor. So you can remember this pump lecture. So when volume flow rate lower and pressure rate higher or head higher, so in that case we go for positive displacement type. So here in compressor system for air conditioning or refrigeration system, the compressor will be positive displacement type, and screw compressor is a positive displacement type compressor. Okay, so they are using twin rotor screw compressor they are using. Okay, mechanically cleanable flooded heat exchanger, chlorine free, this one R134A. Later we'll discuss in details about refrigerants. Multi-pipe heat exchanger also they are using. Okay, so you can go through the again heat exchanger lecture. What is multi-pipe heat exchanger? Multiple pipes will be there, so cooling rate will be much higher. Okay, so their Aqua Force 30, this is their product, actually this picture shows. Okay, now I told that there will be basically two types of refrigeration system. One will be vapor compression, one will be vapor absorption. Many other types also there, but let's first focus on vapor compression. How does it work? So vapor compression system will have one compressor. Compression term is there, that means one compressor must be there. So let's draw one compressor first. Okay, so compressor, what is it is doing? It will be compressing, no, it will be compressing refrigerant and condenser. Okay, after condenser there will be one throttle valve, then evaporator. So I'll put name 1, point marker, or state 1, state 2, state 3, state 4. Now I'll be putting this one in TS diagram. Again you draw this similar to Rankine cycle, one vapor envelope drawing. your compressor, this is compressor, this is throttle valve, or expansion valve. Okay, so TS diagram, condenser will be reducing temperature, this is your compressor, then four, 1, 2, 3. So now you can see this one just opposite of your Rankine cycle actually. If I can draw TS diagram, Rankine cycle, I had like this, right? So A, B, C, D, Rankine. Okay, so Rankine cycle you can see compressor, instead of compressor in Rankine cycle I had turbine. Okay, so compressor we are giving power to compress air, but in turbine we expanded fluid, right? So it is similar to just opposite of Rankine cycle actually, you can see. But 2 to 3 is called expansion valve, and it is irreversible process. Okay, this is irreversible process. Versible. So 2 to 3 is irreversible process. 1 to 2, 1 to 4, 4 to 1 compressor, we are assuming, let's say adiabatic or entropy constant. Okay, 1 to 2 is your condenser, so that means it is releasing heat. Okay, so 1 to 2 is releasing heat. And evaporator, what is happening? It is taking heat from surrounding. Okay, evaporator taking heat from surrounding. So your evaporator, this room is cooled, right? So this evaporator is taking heat from this room. Okay, so evaporator is nearby here, but condenser it will be outside the building. Okay, and throttle valve, so condenser and compressor will be outside building. Compressor, because compressor will be noisy, one motor will be there, then screw compressor or scroll compressor will be there, so those will be continuously running. Because of that one, some noise will be coming. So condenser and compressor will be outside building if it is split air conditioner. Okay, but if you are thinking about window air conditioner, then everything will be together in one box. Okay, very small compact system. Now TS diagram you understood, like 2 to 3 on throttling happening or expansion happening, so there entropy increasing but is irreversible process. 4 to 1 compression happening, because of compression gas temperature will be rising. Okay, so compression, then you have to reduce temperature, so 1 to 2 you reduced. Okay, heat will be released. When reduced, actually you made liquid. Compressor compressed your refrigerant, the fluid is flowing, fluid called refrigerant. Okay, so when fluid is flowing through the loop, that fluid is called refrigerant. Refrigerant 1 to 2 phase change occurring, constant pressure. Okay, so 1 to 2 phase change occurring, P constant, right? And 2 to 3 pressure changing but phase change not occurring. 2 to 3 irreversible process, pressure changing. Okay, and 3 to 4 what is happening? 3 to 4 is evaporation happening. Evaporation happening means you are giving temperature from room temperature is taking and phase change occurring. So 3 to 4 phase change occurring. Okay, 3 to 4 phase change occurring. Now the system 3 to 4 phase change occurring means you created gas, evaporated gas, you or steam or gas you created, 4 to 1 compressed it. Compressed means you increase temperature, condenser, release heat, again you make liquid at higher pressure, you are making liquid. When it is going through throttle valve, pressure changing, so pressure changing and it is going to your evaporator system. Then evaporator systems at lower pressure, lots of evaporation will be happening, vapor will be coming out. Okay, so that will be taking lots of latent heat. When latent heat is taking, so latent heat it will get from the room, okay, or if it is fridge, from food item it will take latent heat, and food item will be cooler, room is cooler, then it is liquid again. This at 4 it is liquid, so 4 is it is vapor, right? So 4 to 1 compressing vapor. Okay, it is clear now.